Today we're going to talk about a new chapter. So this chapter mainly we are going to cover several materials. The first thing we're going to talk about is the motions of the planets, and then we are going to discuss a brief history of astronomy. And after that, we're going to focus on several laws related to planetary motion. One is Kepler's law, the other one is Newton's laws, and then finally we're going to talk about Newton's gravitational law. So the first thing we are going to mention is motions of the planets. Okay. In ancient times, people believed that Earth was the center of the universe because sun, moon, and stars, they all have very simple movements in the sky, which is consistent with an Earth-centered system. However, as time went by, people discovered more things, such as planets move with respect to fixed stars, they change in brightness, they change speed, they also have retrograde motion. Some of these are very difficult to describe in Earth-centered system. So, one thing I would like to point out is retrograde motion of planets. Okay, so as you can see from this diagram over here, okay, on September 1st, 2009, this planet was here. And then October 1st, 2009, the planet moves to here, this position. It continues to move until some point here around January 1st, 2010, it's going to start to move in the opposite direction, and then until sometime around March 1st, 2010, it's going to change the direction again, okay, and then keeps moving towards the east direction. So in other words, the planet initially was moving towards east direction, and then changes direction, moves towards west direction, and then after some period of time, it changes back to the eastward motion in the sky. So the backward motion is referred as retrograde motion, okay, and then forward motion is referred to as prograde motion. So astronomers, they were trying to explain the motion of the planets against the background of fixed stars, especially, okay, why the planets do not move uniformly against the background of stars, but instead appear to stop, move backward, then move forward again. So, of course, for Earth-centered model, which we say is a geocentric model, okay, they were trying to build some model to try to explain these planetary motions. So for instance, okay, here is the Earth, that's the planet, okay, so they assume that, okay, the planet is moving along an epicycle, okay, the small circle here is an epicycle. In the meantime, this epicycle is moving around the Earth. So around the Earth, along the path, which is called a deferent, okay, so remember, in this model, there are two paths, okay. The first path, the planet is moving around the epicycle. The second path, okay, the center of the epicycle is moving along deferent around the Earth, okay. How can we use this model to explain the retrograde motion? So if you look at this diagram here, so when the planet is in this half of the epicycle, because the epicycle is moving this direction and the planet is also moving this direction, okay, so these two motions, if you add these two motions together, it seems that from the Earth, the planet is moving eastward direction, or sometimes we say direct motion. On the other hand, if the planet comes to this part of the epicycle, but the epicycle itself is moving this direction. But notice that epicycle moves slowly eastward along different, but planets move rapidly westward along the epicycle. So if you add these two motions together, as seen from Earth, the planet is going to move eastward because it's more rapidly. This is more slowly. Okay, so that's how people used geocentric model to try to explain the motion of this planet, the special kind of motion the planet moved over a certain period of time. However, if you want to add all the planets in the solar system together, under this model, we actually, lots of epicycles were needed to be able to accurately track planetary motions. So this model becomes very, very complicated. Okay, and in fact, this model was invented by Ptolemy, so that's why this is called Ptolemy's model. Okay, as you can see, this model is pretty complex. Okay, in science, you know, when something becomes really complex, people started to wonder, okay, whether this is the right direction to go, or we should, you know, something was wrong and then we should do something differently. Okay, so on the other hand, if we trying to explain this motion using heliocentric model, and this model becomes very simple. Okay, as you can see now in heliocentric model, Sun is at the center of this model, and all the planets are moving around the Sun. Okay, so this is the Earth's orbit, and this is the planets. Okay, that special planet's orbit. So as you can see that we're trying to, obviously we're trying to observe this planet from Earth point of view, but those two planets, both Earth and the planet, actually they are moving around the Sun. So when they are at position 1, we're trying to look at this planet from Earth. So as you can see, we project that as if this planet is in this position in the sky. Now, these both planets, they keep moving, so when they are at position 2, you're going to see that this is going to appear in the sky at this position. So it keeps moving until, okay, until, as you can see, at position 5, the planet is going to be here. And then at position 6 here, now if you notice that, so at this position, the Earth is actually the Earth, because the Earth is moving around a smaller orbit. Okay, the planet is moving around a bigger orbit. So at some point around position 6, Earth is moving ahead of the planet now. So as you can see, so when we are observing this planet from Earth point of view, it looks like, you know, this planet actually appears in the sky in this position. So it's part of the retrograde motion now. And then at 7th position, the planet appears in the sky in this position. After that, okay, and the planet is going to continue actually change its position. It's going to continue to move along the east direction. Okay, we call this retrograde motion. Okay, so that's heliocentric model, which is much simpler than the previous model. Okay, one of your labs actually, I think, was asking you to explain why Mars, because you found out the coordinates for Mars during a certain period of time, and then you need to explain why Mars actually were doing that kind of motion. So I would like you guys to think about both of these two models. One is a geocentric model, the other one is heliocentric model.